metallurgical process for the extraction of metal from its corresponding ore can be done by three-step process. First step, concentration of the ore. Second step, extraction of crude metal. Third step, refining of crude metal. Concentration of the ore is nothing but removal of impurity from the ore particle. It can improve the percentage of yield. Depending upon the nature of ore, we can select the suitable concentration method. Suppose the ore is oxide one, mean we can take the gravity separation method. Suppose the ore is sulfide in nature, means we can take flotation method. Suppose it contains magnetic and non-magnetic particle, mean we can take magnetic separation method. Or then we may use the different types of chemical method. So the concentration of the ore can be useful for the removal of impurity from the ore, as well as it will increasing the percentage of yield of metal. Second step, extraction of crude metal. It can be done by two-step process. First step, the conversion of concentrated ore into metal oxide. Then second step, the metal oxide further reduced to metal by using suitable reducing agent. Still, the crude metal consists of some impurity. It can be removed by the third step process, refining of crude metal. Normally, we may refine the crude metal by distillation process or liquefaction process or electrolytic refining process or zone refining process or vapor phase process. Concentration of the ores. Naturally occurring ore, which are also associated with non-metallic impurities, rocky material and siliceous matter, which are called as gangue. We can remove the impurities or gangue particle from the ore is called as concentration of the ore. By the concentration process, it will increasing the concentration of the metal present in the compound. It is the preliminary step for the extraction of metal from its ore, or then that is the first step for the metallurgical process. There are several types of method available for the concentration of ore, but depending upon the nature of ore, types of impurity and then environmental factor, we can choose the suitable method for the concentration of ore.
Hydraulic washing. This is based on the differences in gravities of the ore and the gangue particles. It is therefore a type of gravity separation. Cassiterite is concentrated by this method. Will-fly tables are specially made tables for washing of ores. The ore is ground to a fine powder in ball mills. Then the powder is washed with a current of flowing water. Lighter gangue particles washed away and the heavier ore particles remain behind at the bottom.
Froth flotation method. It is another one important method for the concentration of ore, especially sulfide ore. Sulfide ore can be concentrated with the help of froth flotation method. For example, galena, lead sulfide, zinc blende, zinc sulfide, can be concentrated with the help of fourth flotation method. The fourth flotation method contains a simple principle is the metallic ore particle which are preferably wetted by oil. So it can be separated from gangue particle or impurity. In this fourth flotation method, the crushed ore or the powdered ore suspended in water, and it also mixed with pine oil or eucalyptus oil. The pine oil or eucalyptus oil used as a floating agent for this process. Now, the crushed ore suspended in water mixed with pine oil, further mixed with a small quantity of sodium ethyl xanthate. The sodium ethyl xanthate acts as a collector in this process. The ore particles are collected with the help of sodium ethyl xanthate for this process. The whole mixture, crushed ore, suspended in water, mixed with pine oil, mixed with sodium ethyl xanthate, kept in a large iron tank. Then we can insert a air blower inside the large iron tank. With the help of air blower, we can agitate the ore particle. With the help of agitation, it forms like a froth because it is not wetted with water. Further, the ore froth particles are combined with sodium ethyl xanthate. It is also not wetted with water particle. We already know that sodium ethyl xanthate used as the collector molecule in this process, which collect the froth particles of ore and move towards the top of the iron tank. Further, the froth particles of ore can be separated from the iron tank or it can be collected in another one vessel. These vessels further go for the next step of the metallurgical process. Now, the iron tank which consists of the impurity or then which consists of the water wetted gangue particle which is settled at the bottom of the iron tank. It can be removed. Now, I take simple example for the concentration of galena. Lead sulfide is also called as galena, which also consists of the impurity of zinc sulfide. Here both are sulfide ore. So both forms the froth and it can be floated to the top of iron tank. In order to prevent the floating property of zinc sulfide, we can add a small quantity of sodium cyanide to the mixture. So we can take galena, lead sulfide which consists of the impurity zinc sulfide. Further we can mix with the sodium cyanide. The sodium cyanide used to depress the floating property of zinc sulfide, or it is used to reduce the floating property of zinc sulfide. So here zinc sulfide formed as a layer of zinc complex sodium tetracyanozincate, which is formed as a complex. So we can easily concentrate the galena ore, lead sulfide ore, and it can be concentrated.